Assalamu alaikum everybody. Okay, today in computer architecture we are going to discuss Booth's algorithm that is primarily used for multiplying signed numbers, and it's a very efficient algorithm. So let's start. Okay, so you can see the flowchart of Booth's algorithm. It's a little different from the one we have discussed earlier in the previous session, and you can see here I'll describe it briefly first, and then we'll go into the details and perform step-by-step calculations. And you can see we have already reserved some registers here, and we have a multiplicand. As you already know, the multiplicand, the other one is the multiplier by which we are going to multiply, and there was a count which is counted, which is used to make sure that you perform the actual number of steps, the cycles. And then we have a, which will be initialized as 0, and q minus 1 will be initialized as 0. Okay, so here's the flowchart, and what we need to know first is that we are going to check these q and q minus 1 initially and make a decision. And for that we have two bits here, q0 and q minus 1. So what possibilities are that it can either be 0 0, it can either be 0 1, it can either be 0 1 0 or 1 1. These are the four possibilities. So if you check these two possibilities, the bits are same, and these are the two other conditions which are possible. And this is what we are going to check here during this step. And as you can see that if the bits are same, either 1 1 or 0 0, then you will go straight to the arithmetic shift operation. I'm not going into details because we have already discussed this in the previous sessions, so you know what is arithmetic shift. But there is a difference in this step, and there is a additional step, so I'm going to tell you about that later. And when you during checking, if you get 0 1, that is q0 is 0 and q minus 1 is 1, then you will be performing this step, that is a plus m, and the contents transfer to a, that is the result. And if you get 1 0, you will be subtracting a if m from a, that is a minus m, okay, and the result will be put. So the decision to make at this step is that if it is 0 1, then you will be adding a and m, and if there is a 1 0, then you will be subtracting m from a, that is a minus m. And the bits are same, then you will be going straight to the shift operation. Finally, after applying the shift operation, you will check the count. Remember, the partial products which produce during the multiplications, or if you go and see another way, if the bits in the multiplier will be equal to the number of cycles that has to be performed. So if q is 0, that means you have performed the required number of cycles, then you will be going and ending this program. But if it is not, then you will be going back and checking q0 and q minus 1 again, and this will continue. If you have multiplier of 4 bits, then this cycle will repeat 4 times, and after that you will get a count equals to 0 because you are decrementing. And ultimately, if it is 0, then you will be terminating or ending your program. So this is the brief description of this algorithm. I am going to apply it to example, and then you will be able to understand better how it is working, because I'm going to use example and multiply 7 by 3. So let's see that. Okay, so this is the example in which I'm going to multiply 7 and 3, and you can see here I'll just repeat this part, that m will be carrying the multiplicand, q will be carrying the multiplier, and a will be the accumulator which is going to hold the result. And now if we use 7, this is 7, as a multiplicand and this is 3 as multiplier. So this is the binary bits and you are doing 4. So this is what you are going to see. The multiplicand is M, multiplier is Q, and the next step is to decide and check the values of Q0 and Q minus 1. So what we are going to do here is that we will check the values of Q0, that is this one, and Q minus 1, that is 0. And when you see it, you will find that it's 1 and 0, which means that you have to subtract A and M. This is what you have to do and transfer the result to A, and this is M and this is A. So if you subtract A minus M, then you should be getting this value. Okay, the next step is shifting right. Shifting right means that what you are doing is, first this will go as it is. This will transfer here, and this will come here, and this one will come here. This one 0 0, this 0 shifted. Now this is a tricky part. What happens is that this MSB, the leftmost bit, will be copied and retained. This is the thing. This is called automatic shift, and I'm repeating that the last bit, which is this one, will be transferred to the bit on the right side, and it will also be retained. This is what you need to understand here. Okay, so shift right happens, then the next cycle start, and next cycle start because the count is not equals to 0. The next step will be to check whether Q0 and Q1 are same or not. So in this case we have 1 and 1 here, which means same, and when they are same, what you are going to do is you are going to repeat skip the part of addition or subtraction and go straight to the arithmetic part. So here you can see we have omitted this shift part, the first part in which you either subtract or add, and you go straight to the shift part. And in the shift part again, what you can see, I'm going to clear it, and you can see that this one is transferred here, this 0 is here, 0, this one here, this 0 moves here, 1, and this one comes here, this one comes here, and is repeated also. So the second cycle completes. In the next cycle, you will again check the values of Q0 and Q minus 1, which are now 0 1, which means that you will be adding and putting the result in A, and you can see here that it is added, this value is added to this, and you get this one. Okay, the next step will be shifting again, the arithmetic shift. This zeros goes here, this one, I'm going to be a little faster now, this one, this 0, and this 0 repeats itself. Finally the fourth cycle and the last in this case, and the last cycle, what you are going to do again, you are going to check bits Q0 and Q minus 1, and here you can find that both are same, that is 0. So you will be skipping the subtraction and addition part, and you will go straight to the shift part, where you will just shift the values. You can see the values shifting, and this value repeating itself. So the final answer is here. You can see it's so this is the final answer, and if you convert this binary you will find that it's 21, and we know that 7 multiplied by 3 is equal to 21. So this is the answer, and this is the correct answer, and that is it for the Booth algorithm. I hope you will find it understandable. You have find it understandable, and you can work out your example yourself. Just remember to do the arithmetic shift properly and follow the flow chart, which is this one, and that is it for today for this session. Thank you very much, and